To understand how to stop inflammation, we must first define it biologically. Acute inflammation is a survival mechanism, a necessary response to trauma or infection. Chronic inflammation, however, is a maladaptive state where the immune system remains perpetually activated, damaging healthy tissue. This video analyzes 5 specific ingredients that intervene in this process at a molecular level, inhibiting the signaling pathways that drive chronic disease. Ingredient 1. Curcumin, the NF-κB inhibitor. The primary bioactive compound in turmeric is curcumin. Its potency lies in its ability to inhibit a protein complex known as nuclear factor kappa B, NF-κB. NF-κB is often called the master switch of inflammation. Under normal conditions, NF-κB is held inactive in the cytoplasm by an inhibitor protein called ICBA. When the body is stressed, an enzyme called IKK destroys this inhibitor, allowing NF-κB to enter the cell nucleus and trigger the expression of inflammatory genes. Curcumin chemically blocks the activity of IKK. By doing so, it prevents the inhibitor from being destroyed, effectively keeping the inflammatory switch in the off position. Ingredient 2. Omega-3 fatty acids, the resolvers. Most anti-inflammatories work by blocking a signal. Omega-3 fatty acids, specifically EPA and DHA, work by activating a resolution phase. Through enzymatic conversion, these fatty acids are transformed into bioactive lipid mediators known as resolvins and protectins. These molecules actively stop the infiltration of neutrophils, white blood cells, into tissue and signal macrophages to clean up cellular debris. Furthermore, they inhibit the production of arachidonic acid-derived eicosanoids, such as prostaglandin E2, which are responsible for pain and swelling. Omega-3s do not just suppress inflammation, they chemically resolve it. Ingredient 3. Sulforaphane, the NRF2 activator. Found in high concentrations in broccoli sprouts, sulforaphane operates through the NRF2 pathway. NRF2 is a transcription factor that regulates the expression of antioxidant proteins. Under oxidative stress, sulforaphane activates NRF2, which then binds to the antioxidant response element, ARE, in your DNA. This triggers the production of endogenous antioxidant enzymes, such as glutathione S-transferase. Unlike direct antioxidants, like vitamin C, which neutralize free radicals one-on-one, sulforaphane triggers a genetic response that allows the cell to produce its own defense enzymes for days. Ingredient 4. Epigallocatechin gallate, the cytokine suppressor. EGCG is the major catechin found in green tea. Its primary mechanism is the downregulation of pro-inflammatory cytokines, specifically tumor necrosis factor alpha, TNF-α, and interleukin-6, IL-6. Research indicates that EGCG suppresses the phosphorylation of proteins in the JAK-STAT pathway, another critical route for inflammatory signaling. Additionally, EGCG acts as a scavenger of reactive oxygen species, ROS, reducing the oxidative stress that often triggers the inflammatory cascade in the first place. Ingredient 5. Gingerol, the COX-2 inhibitor. Gingerol, the active compound in ginger, functions similarly to non-steroidal anti-inflammatory drugs, NSAIDs, but with a higher degree of selectivity. It inhibits the enzymes cyclooxygenase 2, COX2, and 5-lipoxygenase, 5-LOX. These enzymes are responsible for biosynthesis of prostaglandins and leukotrienes, lipid mediators that cause pain and fever. Crucially, data shows that gingerol inhibits COX-2 without significantly inhibiting COX-1, the enzyme responsible for protecting the stomach lining. This makes it a distinct biochemical tool for managing inflammation without the gastrointestinal risks associated with synthetic QX inhibitors. Conclusion: inflammation is not a random event. It is a chemical cascade. By utilizing compounds like curcumin, resolvins, sulforaphane, EGCG, and gingerol, we can intervene in these specific pathways, blocking NF-κB, activating NRF2, and inhibiting COX-2, using biological data to manage physiological stress.